Hello students, today we are going to take up the topic potassium permanganate. So let us start this topic with a very good thought. It is very easy to defeat someone, but it is very hard to win someone. The learning outcomes from this session is we will be able to know about the structure and shape of potassium permanganate, equation of extraction of potassium permanganate from pyrolusite ore, oxidizing nature of potassium permanganate, that is KMnO4, in acidic, alkaline and neutral medium, and its uses in redox reactions. So let us see the structure of potassium permanganate, KMnO4, and here you can see, if you find the oxidation number, that is +7. So you will find the structure, the 7 bonds are there, 2, 4, 6, this 7, and this thing you have to keep in mind, and one negative charge is there for an ion MnO4 negative. So this is permanganate ion. Okay, and oxidation number is 7 for manganese and tetrahedral in shape. So the next is equation of extraction from pyrolusite ore. So what is pyrolusite ore? Is MnO2. So we are fusing pyrolusite ore with KOH in the presence of oxygen, and on heating we are getting potassium manganate. Please see that KMnO4 and potassium manganate. So here color also is different. Here green is there, so purple will be there. And here also oxidation number also difference. If you calculate the oxidation number, 4 into 2 minus 8, minus 6 and plus 6. Here oxidation number would be plus 6, and here oxidation number was plus 7. We have understood it in the previous structure. And here the first step is to convert the pyrolusite ore into potassium manganate, which is green in color. And potassium permanganate, then we are oxidizing. So we can use these oxidizing agents like chlorine and ozone and carbon dioxide. So these three oxidizing agents you can use to convert K2MnO4 to KMnO4. Now you see how chlorine is acting as oxidizing agent. We can see from here. So here it is +6 oxidation state, and there is +7. So oxidation takes place, and who has done is chlorine. Chlorine is itself getting reduced. So you can see that a 0 oxidation number here, 0 is changed to -1. So reduction takes place. So chlorine undergo reduction and act as oxidizing agent in this case. Similarly, ozone will also be acting as oxidizing agent, as well as carbon dioxide also. So now here you can see the oxidizing nature. Oxidizing nature in 3 different medium, that is acidic, neutral and alkaline. So let us see first the acidic medium. So this number I have given, this is to help you to write the balanced chemical equation very fastly and accurately. In the next video we will be able to see about the reactions. Okay, so 2 KMnO4 plus 3 H2SO4 give rise to K2SO4, 2 NSO4, water and oxygen. So here 5 oxygen we can get from this reaction between KMnO4 and sulfuric acid. So this is nascent oxygens, and this oxygen, so because this is an oxygen provider, so we can say that it is an oxidizing agent. That's one thing. Second thing is, if you see from here, its oxidation number is 7, and here if you calculate the oxidation number would be 2. So 7 to 2. So change in oxidation number is decreased. So it means KMnO4 undergo reduction. So a substance undergo reduction act as oxidizing agent. So similarly, this is an ionic equation. So very easy to write ionic equation. You have to just split this into KMnO4 into ions. K plus MnO4 negative plus 6H plus 3SO4 2 negative, 2K plus and SO4 2 negative 1 and 2 Mn2 plus and 2 sulfate and 3 water as such. So this way you can get the answer. So please see that all this is the basic chemistry level you should be aware of, like valency of potassium is 1. Like sulfate valency is -2, manganese valency is +2. So this is the basic things of chemistry. So you need to just use your intellect, so you will get the correct ionic equation as well. Now here is, if you see the basic medium, so basic medium is actually basically we are adding the KOH, that is the base. KMnO4 is converted to K2MnO4, and K2MnO4 when you dilute with water, or water is already there, is further undergo reaction to form MnO2. Okay, so here in this case KMnO4, if you add these two reactions, the overall equation would be KMnO4 plus water give rise to MnO2 plus KOH plus 3 oxygen. Here you are getting 3 oxygen. In the previous acidic medium you were getting 5 oxygen. So it means the oxidizing agent, the best would be acidic medium, because it is giving us 5 oxygen. Similarly, you can write the ionic equation in the similar manner which earlier I have explained to you, like K plus MnO4 negative and water as such we can write, 2 MnO2 also as such we can write, 2K plus and 2 OH negative. So this way we can get the balanced equation. So we have to balance the charge also, therefore might be the multiplication might. Next is neutral medium. In this case, neutral medium 2 KMnO4 plus water give rise to 2 MnO2 plus 2 KOH plus 3 oxygen. This equation is exactly same as previously we have did. Previously we have done this reaction. If you see, 2 KMnO4 plus water give rise to 2 MnO2 plus 2 KOH plus 3 oxygen. So you can see from here that equation is exactly same. There is no change at all. Next is uses. So uses of potassium permanganate is, it is used as disinfectant. It is also used in the laboratory reactions, and it's also used in the base reagent in detecting unsaturation. In +1 you have done to test between the alkene and alkyne. So you can use KMnO4 and KOH, both will give the test. Because saturation and unsaturation. So if you test between alkane and alkene, it is possible. If you test between alkane and alkyne, that is also possible. If you want to distinguish between alkene and alkyne, that is not possible. You have to use ammonical cuprous chloride solution or Tollens reagent. Okay. So similarly, in volumetric analysis also it is used for estimating the ferrous salts. So in the next video, you will be coming to know about some reactions of KMnO4 where we see that ferrous salts are converted to ferric. Oxalic acid is converted to carbon dioxide and water. H2O2 will be converted to water and oxygen, and further Ki would be converted to K2SO4 and iodine gas. So these are some of the uses of potassium permanganate. And let us see some questions we can just discuss. Calculate the equivalent mass of KMnO4 in different medium. Equivalent mass, the general formula you should be aware of, that equivalent mass is equal to molecular weight divided by valency. Now you see any equation, you can see the change in oxidation number. Here +7 was there and it changes into +4. It means change in oxidation number is 3. So equivalent weight is equal to molecular weight of KMnO4 divided by the change in oxidation number. Similarly here you can find the oxidation number change is, here it is KMnO4 is +7 and it's +2. So 5 change is there, so divided by 5. Similarly here also it is same. Alkaline and neutral medium is same, so divided by 3. Okay. So now let us draw the structure of manganate and permanganate. So see here what is the difference. Please see, oxidation number here it is -8 +7 and here it is +6. So it will form 6 bond, 2, 4, 5, 6. Similarly here 2, 4, 6, 7, 8. And please do remember that K2 MnO4 2 negative is there, so 2 negative charge here, negative. Okay, so this way all these things you should keep in mind and write the 3 reactions for converting K2MnO4 to KMnO4. Previously we have done this. I told you already, these are acting as oxidizing agents. So these are the 3 reactions. This we have done already. And carbon dioxide will be converted to MnO2 and K2CO3, and water O3 is converted to KOH and O2. So this is the easiest reaction. Better to remember this instead of all these two if they have not asked specifically. Okay, so I am happy that and sure that you have understood this concept in a good manner. So great job. So let us repeat the thought. It is very easy to defeat someone, but it is very hard to win someone. Thank you.